In this video, we're going to find out what forecasting method we should be using if we have a linear trend in our data. To establish what forecasting method we should be using, we should first be creating a time series pattern and try to figure out what pattern is exhibited within the data. And it is the pattern within the data that will determine which of the forecasting methods we will use. If you need a refresher on how we establish what trends are in the data, I would suggest that you go back and review the 2.3 videos. For the purpose of these videos, I will be shortcutting through part A of the question, the part about constructing the time series and identifying the pattern. I will be merely focusing on the forecasting method itself. So as we said, glancing over part A, if we do create a time series pattern, looking at the time series, there appears to be an upward linear trend pattern in the data. And because our sales are simply broken down year by year, we're not really given any secondary time period where we can look further into it and see if there's a seasonal trend as well. So in this case, we are simply going to forecast based on the fact that we have a linear trend pattern. Now, if we recall what our least squares equation gives us, the least squares equation really is our predictive model for what the sales are going to be. So what we would do if we have a linear trend, we are simply going to forecast our least squares equation into the future and use that as our predictive model of what will happen as we go into years 11, years 12, and years 13. So we're looking to establish here a forecast for the next 3 coming years. As we said, years 11, 12, and 13. In order to do that, we are going to need to establish what the equation of this line is, which can be done from our regression analysis tool. So under data, data analysis, regression. Remember, the y input is always what we're trying to predict. In this case, we're trying to predict our sales. The x variable or independent variables are what are we using to make that prediction. So what we're using is simply the increasing time that we have. So our independent variable here is time. We will include labels, select an appropriate output range, hit OK. From our regression output, we get that our predictive model is based on the equation that y hat is equal to 20.4 plus 1.1x. So in order to make our predictions for years 11, 12, and 13, we simply need to sub in our values for x into that equation. Or I can recreate that by simply saying it is equal to, I'm going to absolute reference anything out of the regression output. So I'm going to absolute reference, I always want 20.4. Plus, we always want 1.1, so absolute reference that as well. And now multiply 1.1 by our x value. Remember, x value is time, in this case our years. So our prediction for year 11 is that we have forecasted sales of 3,250 bicycles. And because we use cell references for everything, where we use absolute references from anything from the regression output, and anything that was linked to our x values, our independent variable, in this case only the one time, was not absolute reference, we can simply copy and paste that formula down. We should also be able to see, because of the linear upward trend, year after year, our sales are progressively getting slightly better than the previous year. So year 11, we're projecting 3,250 units to be sold. Year 12, 3,360. And year 13, 3,470 units.